Hello, my name is Protocol and I welcome you back to another tutorial. In this tutorial, I will be proving some trigonometric identities. Let's consider a right angle triangle as shown below. So we have this. Okay, so let this angle be theta and this is 90 degrees. So we have x here, y here, and this is our radius. Now, we know from the diagram that sine theta is equal to opposite over hypotenuse. So that is y divided by what? R. So we have y over r. We also know that cos theta is equal to adjacent divided by hypotenuse. So we have x divided by r. So x divided by r. You also know that tan theta is equal to opposite over adjacent. So we have y divided by what? X. So y divided by x. We also know that cosec theta is equal to 1 divided by sine theta. So what is sine theta? Let's check it. Sine theta is y over r. So we now have this to be equal to 1 divided by y over r. And when you simplify, we are going to have r over y. So cosec theta is equal to r over y. So let's go ahead and represent cosec theta with that. So we have r over y. We also know that sec theta is equal to 1 over cos theta. And what is cos theta? Let's check it. Cos theta is x over r. So it means that I will now have 1 divided by x over r. And when I simplify, I'm going to have r over x. So sec theta is equal to r over s. So let's go ahead and represent sec theta with r over x. We also know that cos theta is equal to 1 divided by tan theta. And what is tan theta? Let's check it. Tan theta is y over x. So our cos theta will now be equal to 1 divided by tan theta, which is y divided by x. And when you simplify, we are going to have x over y. Therefore, cos theta is equal to x over y. So let's represent cos theta with x over y. So x over what? Y. Now, in order not to get confused about these trigonometry ratios, cosec theta, sec theta, and then cos theta, this is a trick you can use. So we have cosec theta to be equal to, also have sec theta to be equal to, and last we have cot theta to be equal to. Now, the trick is that you look for the third lattice in each of the trig ratios. So the first one, cosec theta, the third letter is what? X. It means that the x here represents sine. So we're going to have 1 divided by sine theta. Now, looking at sec theta, the third letter is what? C, which represents cos. So you now have 1 divided by cos theta. And lastly, we have cot theta. And clearly, the third letter is what? T, which represents what? Tan. So we have 1 divided by tan theta. So this is a trick you can use in order to remember all these trigonometric ratios. Now, let's proceed with our work. Okay. So, from the diagram, this diagram, we know that using Pythagoras theorem, when you square the opposite and add it to the square of the adjacent, you're going to get the square of the hypotenuse. That is, the sum of the square of the two shorter sides will be equal to the square of the longer side. So, the equation that you're going to have is x squared plus y squared will be equal to r squared, using the Pythagoras theorem from the diagram. Okay. So this is the equation that we'll be having. Now, we have x squared plus y squared equals r squared. Let's divide each of the term by r squared. So we'll be having x squared over r squared plus y squared over r squared, and this will be equal to r squared over r square. This is the same as x over r all square plus y over r all square, and r square divided by r square, we are going to get what? 1. Good. So what is x over r? Let's check it and see. X over r is cos theta. So in place of x over r, I will write cos theta. So I now have cos square theta plus what is y over r? Let's check it. Y over r, as you can see here, is sin theta. So in place of y over r, I will have sine square theta, and this is equal to 1. So this is our first proof. This is an identity in trigonometry. Let's come back to our equation. So we have s square plus y square to be equal to r square. Now let's divide each of the term now by s square and see what will happen. So we have s square divided by s square plus y square divided by s square, and this is equal to r square divided by s square. Good. So s square divided by s square, I will surely get 1. So I have 1 plus, and this is the same as y over x all square equals, this is also the same as what? R over s all square. So now I have 1 plus, what is y over x? Let's check it. Y over x, y over s is tan. So we have y over s to be what? Tan. So in place of y over s, I'm going to have tan length. So I have tan square theta to be equal to r over x. So let's check r over s. So clearly r over s is sec theta. So we have sec square theta, and this is also identity in trigonometry, and that is the proof for that. Let's come back to our equation, this equation. So we now have x square plus y square is equal to r square. This time, let's divide each of the term with y square. So if we do that, we are going to have s square divided by y square plus y square divided by y square, and this will be equal to r square divided by y square. So this is the same as x over y all square plus y square over y square. We shall surely get 1. So 1 is equal to r square over y square is the same as r over y or square. What is x over y? Let's check it. X over y. Let's check it. So x over y, as you can see, is cos theta. Therefore, in place of x over y, I will have cos square theta plus 1, and this will be equal to r over y. What is our r over y? R over y. Let's check it and see. Clearly, r over y is cosec. So in place of r over y, I'm going to have cosec square theta. And this is also an identity that is used in trigonometry. So we are able to prove these identities. 1, cos square theta plus sine square theta is equal to 1. And we also prove that 1 plus tan square theta is equal to sec square theta. And lastly, we are able to prove that cos square theta plus 1 is equal to cosec square theta. Thank you so much for watching the tutorial, and don't forget to share the videos. I thank you all. Bye bye.